So this lesson number 8 for Math 20-1, lesson number 5 for 20-2, looks at problem-solving questions in which you're not actually told what to use to solve it. So when we were looking at the previous lessons, the lesson on cosine law meant that you were using the cosine law. The lesson on the sine law meant that you were probably using the sine law. In this case here, you're given a problem and you're asked to solve for a missing measurement and you're not told how to do it. So the two things to remember, if you have a right triangle, you revert back to SOHCAHTOA. That's what right triangles use, is SOHCAHTOA. If you are not given a right triangle, if it's called an oblique, so it could be an acute, obtuse, it's a non-right triangle. To figure out between using the cosine law and the sine law, start with the cosine law. The cosine law can be used in two conditions: when you have all three sides, or when you have two sides in the contained angle. So when I can draw the letter C. So if I can draw the letter C around my triangle components, the parts that I'm given, I can use the cosine law. If I have all three sides, I can use the cosine law. If you can't use the cosine law, then you're using the sine law. That's the default. So what we're going to look at first is some review about circles. It goes back to grade 9. Yay! Circle geometry. The perpendicular line drawn from the center of a circle to a chord. So perpendicular means it's going to hit this chord at a 90-degree angle. What does it do to the chord? Splits it in half. And we have a special word for that? It bisects the chord. So that was one of those ones that we did where if a line bisects the chord, it's going to go through the center of the circle. If a line goes through the center of a circle and it bisects the chord, it has to be at a 90 degree. This is useful because this right here, if I drop a line, now I have a right triangle. So that's where that can be used, is the fact that if I draw this line bisecting this chord, I now have a 90-degree angle. I would be able to then find some other calculations. This one is for this diagram, B and C. The measure of the central angle is equal to what of the measure of the inscribed angle subtended by the same arc? So first of all, subtended by the same arc means from A to C. That's my arc. So I can close all of my angles up by starting at A, going to a point, and then going to C. The central angle goes to the center of the circle. That becomes my central angle subtended by the arc AC. This is my inscribed angle. Goes from A to S to C. Who remembers what the relationship is between these two angle measurements? What is it, Bobby Ann?
It's like the y angle half of it.
Yeah. So the measure of the central angle would be twice the measurement of the inscribed angle. So if the inscribed angle was 30 degrees, the central angle would be 60 degrees. The other theory, or the other property, is inscribed angles that are subtended by the same arc. So in other words, ASC and ARC, what can you tell me about angle Y and angle Z? They're the same. So they're called inscribed angles subtended by the same arc. They are equal. And then the last one, a tangent to a circle. So a tangent is a line that touches the circle in one point. If I draw a line from that point to the center of the circle, which is the radius, what do I know about these two lines? How do they intersect? What kind of an angle? They make a 90-degree angle. And we say that that means it's perpendicular. So a tangent to a circle is perpendicular to the radius of the circle at the point of tangency. So we're going to use that on the next page to solve the first question. In the following diagram, O is the center of the circle and it has a radius of 3.25 centimeters. The distance from Q to R is 2.5. The distance from R to S is 4.7. Calculate the length of PQ. So with some of these, you may find it easier to pull the triangle out of the circle and sketch it so that it's a bit easier to see. If I look at PQR, there's R, Q, and P. Q to R, I was given. It's 2.5 centimeters. Can I figure out the distance from P to R? Given that the radius is 3.25 centimeters? Be double the radius, so what's double 3 1/4? 6 1/2. One last theory or property that wasn't on the previous page. If I have an angle inscribed in a semicircle, what do I know about this angle here? If I inscribe an angle in a semicircle, I will get a 90-degree angle. So angle Q is 90 degrees because it's angles in a semicircle. So how do I find PQ? What kind of triangle do I have? So if I know two sides of a right triangle, how do I find the third? Pythagoras theorem. So in Pythagoras theorem, which is my c squared? The hypotenuse. Which one's the hypotenuse? PR. So PR squared would be equal to PQ squared plus QR squared. So PR I know. PQ is what I'm trying to find out. And QR I know. So I'm going to give you a moment and I want you to finish up the question and find what the length of PQ is. So PQ squared would be equal to 6.5 squared minus 2.5 squared, which equaled 36. To get rid of the squaring, I have to square root. And PQ equals 6 centimeters. Actually, it would just be 6. So in part B, you're asked to calculate the measurement of QPR. That's this angle right here. So I still have my 90-degree angle. This is still 2.5 and this is still 6.5. How do I find angles in a right triangle? What do I use? Go back to the previous page at the top. If I have a right triangle, what do I use to solve? SOHCAHTOA. So in terms of this angle, what do I call this side? What do I call this side? So which trig function has opposite and hypotenuse? Sine. So the sine of angle P will equal 2.5 over 6.5. So then to find angle P, what would I have to do? What do I use on my calculator to find the angle? The inverse. So it would be inverse sine 2.5 divided by 6.5. And what do I get? So inverse sine that, and what do you get? I think something went wrong there. Just give me a second. So now that you're in degree mode, what would that be?
22.649.
So to the nearest whole number? 23 degrees. Okay? So now if I look at the next one, the measurement of SQR. So if I take that circle, and if I was to scribe out Q, R, S, I know that the length of Q to R is 2.5 because we figured that out already. And do I know anything else? Oh, right, because that was given to me. What can you tell me about angle P and angle Q or angle S? Why are they equal? They both are inscribed from that same arc. So they both come from arc QR. So that means that angle S would have to be 23 degrees. So this is not a right triangle. I can't prove that it's a right triangle. I can't look at this and say, well, angle R kind of, well, no, it doesn't. Even the way that it's drawn, it does not look like a 90-degree angle. So the only way that you can say it's 90 degrees is if you have some level of proof. Q we could say was 90 degrees because of the property. It's inscribed in a semicircle. So with this one, because we no longer have a 90-degree triangle, we're either looking at the cosine law or the sine law. So we start with the cosine law. Cosine law can be used if I have 3 sides. Do I have 3 sides? No. It can also be used if I have a side, angle, side. So it's 2 sides in the contained angle. There's 2 sides. Where's the contained angle? Angle R, which I don't have. So I can't use the cosine law, which means by default I'm using the sine law. So I want to find out angle Q. So that would be sine Q is to side Q, which is 4.7, as sine 23 degrees is to 2.5. So to get Q or sine Q by itself, I'll multiply both sides by 4.7. And then I'll have to do the sine inverse of that answer. And what do you get for angle Q? Thank you. Okay, so let's move along into some problem-solving questions. Before we get into problem-solving scenarios, we need to talk about bearings. When it comes to describing direction, there's 2 ways that you can describe direction, and I'm going to go through the first one, bearings first. A bearing of one point from a second point is a way of giving a direction. The diagram shows 2 points A and B and the north-south line through A. The bearing of B to A is a measure of angle NAB, and it's 125 degrees. Bearings are measured from north in a clockwise direction. So it's backwards from what we were doing before with our rotation and our reference angles. A bearing means that I'm looking at north and I'm going clockwise. So if I say to go on a bearing of 30 degrees, it means I look north and I go 30 degrees and that's the direction I'm heading. If I say take a bearing, so a bearing of 300 degrees means I start north and I go 90, 180, 270, another 30 degrees means that I'd be going in that direction. So you're starting at north and you're going clockwise. So if I look at an aircraft, a bearing of 60 degrees, a bearing of 240 degrees, a bearing of 340 degrees, because you're always starting at north. So a liner leaves port and sails 15 kilometers on a course of 37 degrees to a position of Q where it changes course to 270 degrees and sails 12 kilometers to a point R. We need to complete this sketch. For Math 20-2s, this is question number 6 in your assignment. So flip to question number 6 in the practice questions. So we leave point P. We are going on a heading or sailing 15 kilometers on a course of 37 degrees to Q. What this means is if I started at P and I looked at where north is, my bearing of 37 degrees is this. This angle in here is 37 degrees. Not this little piece, not all of angle P, just this part, because I start north and I go 37 degrees. I travel 15 kilometers, and then I get to point Q. At point Q, I change course to a bearing of 270 degrees. There's my north-south line, 270 degrees. So if I think of this, this is 90, 180, 270 degrees. That's all of that part. So this is all 270 degrees. And I sail 12 kilometers to point R. And the question that I have to answer is, what is the distance from R to P, and what is the course? So the course meaning when I'm at R and I'm looking at north-south again, I need to figure out this in here. That's going to be my angle bearing. So take a couple of moments and see if there's information you can figure out about any part of this triangle. Let's say we call this point T. What can you tell me about triangle PTQ? What kind of triangle is it? It's a right triangle, because this, if it goes due north, is going to cross this at a perpendicular line. So if this is 37 degrees and this is 90 degrees, what is this piece right here? So in that triangle, angle Q is 53 degrees. I now have in my triangle PQR, I now know that angle Q is 53 degrees, RQ is 12, and PQ is 15. And I want to know what PR is. How can I find out PR? What can I use?
Look at the cosine.
Not SOHCAHTOA. Why can't I use SOHCAHTOA? What do I need for SOHCAHTOA? I need a 90-degree angle. I need a right triangle. But I can use the cosine law. Thank you, Evan. So the cosine law would be PR squared, or Q squared, would equal 12 squared plus 15 squared minus 2 times 12 times 15 times cos 53. So determine that calculation for me, please. So what did you get?
152.34 cents.
Does that sound right? No, I don't think you did it wrong. I think you forgot a part.
Oh, and then when you square root it, then you get 12.342.
So 12.3 kilometers I have to sail. Okay. The last piece of information that I need is that bearing. So if I go back to this diagram, this right here is 90 degrees. So if I could figure out what angle R was, my bearing would then be the 90 plus that angle R. So what could I use to figure out angle R? Could I use the sine law? Do I know what side Q is now? Yep. Do I have, so I have this, so I could use the sine law, or I could even use the cosine law. I could use the form of the cosine law where I isolate the cos. So it doesn't matter which one I use. Let's say I decide to use the sine law. Sine R over 15 would equal sine 53 over that 12.3 answer that I got previously. To get R by itself, I'd multiply, so I get 15 times sine 53 divided by 12.34. Angle R would be the sine inverse of that answer. Tell me what you get. So what did you get?
76 degrees.
So then the course would be the 90 plus the 76, which would be 166 degrees. So when I get to point R, I would then have to change my bearing to go on a course of 166 degrees to bring me back to P, and I would have to travel 12.3 kilometers to get there. So we'll do one more example. Two aircraft A and B leave an airport at the same time. Airplane A flies on a course of 90 degrees at 700 kilometers an hour. B is at 290 degrees at 600 kilometers an hour. Calculate their distance apart after 12 minutes. So we need the airport. Oh, P for airport. If I'm going 90 degrees, that means I'm traveling east. So there's my airplane A. (290 degrees). So if I imagine there's my due north, I've got 90, 180, 270, so 290 degrees puts me in this direction. And there's B. And the question is, how far apart are these two aircraft after 12 minutes? So this angle in here, Can I figure out what angle P is based on the other information that I have? I know from here to here was how many degrees? 290. So what would be left over in here? What do I have to get up to? 360. So what's left over from 290? And what do I know about this? That's 90 degrees. So what is angle P going to be equal to? 160 degrees. So now I have an angle. Can I find the distance from the airport to airplane A after 12 minutes? Yes or no? How fast does the airplane travel? So 700 kilometers in 1 hour. How many minutes have I traveled? 12. Can I figure out what portion of an hour that is? 12 minutes out of 60 minutes? What's 12 divided by 60? 0.2. So I've traveled 0.2 of an hour. So if it's 700 kilometers in 1 hour, in 0.2 of an hour, it would be how many kilometers? What'd you get, Hannah? And then I can do the same thing with my 600 kilometers per hour. 600 times 0.2. How many kilometers? I now have a side. It's contained angle and a side. What do I use? Cosine law. So use the cosine law to finish this, and that's where we'll stop for today.